When we think about women's health, we typically think about the areas of the body that can only be covered by bikini. We think about reproductive health, we think about pregnancy, and while all of our attention is focused on those bikini boundaries, the disease most likely to kill women is often forgotten. Cardiovascular disease is a complicated puzzle with many pieces. It's the leading cause of death amongst women, killing 1 in 3 women worldwide every year. In fact, the number of deaths associated with cardiovascular disease actually outnumber all of those related to pregnancy-related complications, in addition to female cancers combined. Now, to understand the reasoning why, we must first look to try and solve that puzzle, and that includes looking at a precursor of cardiovascular disease, metabolic syndrome. Metabolic syndrome is a cluster of interrelated risk factors which include obesity, high blood pressure, high blood sugar, and dysregulated fat levels in the body. And it's reaching epidemic proportions worldwide, affecting 1 in 4 individuals. Now, this puzzle doesn't only affect the heart, but it also affects a completely different organ system as well, the liver. Metabolic dysfunction-associated steatotic liver disease, or MASLD, is just a fun way to describe the buildup of fat that occurs in the liver. And this is also reaching epidemic proportions worldwide, affecting 1 in 3 people globally, with around half of those individuals being women. Now, a common assumption with MASLD is that postmenopausal women, in addition to men, are the people who are most likely to develop the disease. And this is because it's assumed that premenopausal females are protected against it. However, this leaves a major gap in our understanding of how the disease actually does develop within this population of individuals. In addition to those questions I have about MASLD, I also have another very important question about metabolic syndrome. Why is it that some individuals with identical risk factor profiles, some including lifestyle factors, some of them develop disease while others just don't? And this can actually be traced back to our ancestry, which are traced through our mitochondria. Our mitochondria are tiny structures that are in our cells, and they carry their own DNA. And differences in this DNA can actually influence an individual's ability to respond to metabolic stress, which adds another piece into that puzzle. So this is where my research comes in which I have a mouse model which isolates those ancestral differences. By inducing metabolic syndrome in both our female and our male mice, I can determine how both sex and ancestry interact in the onset and progression of MASLD. I can help further determine how those inter-individual differences in metabolic disease arise. I can move women's health away from defining it solely based on those bikini boundaries. And I can help solve this puzzle that's been long overdue. Thank you.